In this video lesson, we're going to be learning about the traditional multiplication algorithm. And the word algorithm, all it means is just the traditional way that things are done. It is the standard way that you would see most adults perform multiplication. I am going to be showing you some examples, the same examples we used in the easy method, and showing you how that relates to the standard algorithm. So our first multiplication problem that we looked at in the easy method was 462 times 5. And you'll remember we wrote it 462 times 5. And guess what? The traditional algorithm, we set it up the same exact way, 462 times 5. And in the easy method, when we were multiplying, we started by multiplying the 5 times the 2, which gave us 10, and we put the whole 10 down at the bottom. Then we multiplied 5 times 60. 5 times 6 is 30, plus a 0 is 300. So we put that down at the bottom. Then we multiplied 5 times 4, which is really 5 times 400. And 4 times 5 is 20, plus the 2 zeros from the 100. And we added those together to get our final product. Now that method works fine, but it does take up a lot of room. We have all of this space that we've used up, and once you start multiplying larger numbers, especially if you're multiplying by a 2-digit number, if you have another digit here, you're going to get a lot of confusion, a lot of partial products. So that's why we have the traditional algorithm. The traditional algorithm is like a shortcut. It instead of putting all of these partial products down here, we are going to make some trades up at the top. So watch as I show you. We're going to start the same way. We're going to start with the 5 and multiply times the 1s. So 5 times 2 is 10. But kind of like when we are doing addition, we're going to put the 1 from the tens above the tens column, and the 0 goes in the answer space. Now, one thing that I like to do is put a little plus sign in front of that 1. Well, it's kind of hard with my finger. The reason I do that is because I want to remember that I have to add that 1 after I multiply. Multiply, then add. Always do it in that order. So 5 times 6 gives me 30, plus 1 more is 31. The 3 gets transferred to the hundreds column. The 1 gets put in the answer space. Now I multiply the 5 times the 4. 5 times 4 is 20, plus 3, I like to circle it so I know I've added it in, gives me 23. 1, 2, 3, comma me. So you can see that I've taken up a lot less space. In my answer column, in my answer space, I only have 1 line. Whereas over here, I had all these extra lines, 4 lines total. So this takes up less space. And is quicker. That's why more people use the traditional algorithm. Okay, let's look at another example. Here we have 683 times 4. And let's review what it looked like with the easy method. Written, 4 times 3 is 12. Both parts go down below. 4 times 80, remember this would be an 80. 4 times 8 is 32 plus the 0. All of that goes down below. 4 times 6, which is really 600, is 2,400. So I write that down below. Then I add my partial products to get my total product, 2,732. Now, using the traditional algorithm, it's the same process, just things are written a little bit differently. I start with the 4 times the 3, which is still 12, except the 1 from the 12 goes up. That's a plus sign. That looks terrible. Plus 1. And the 2 from the 12 goes into the answer space. So we still have 12. You have it here as the 1, and here is the 2. So you still have 12. It's just split up instead of being together. Then I multiply the 4 times the 8. 4 times 8 is 32, plus 1 more is 33. The first 3 goes up. 4 times 6 is 24, plus 3 more is 27. Both of those go in the answer space because we're here to transfer to. So I have my same answer, 2,732, but it has taken up less space and it is written more compactly. One more example to look at, 907 times 3. Here we have 907 times 3. 907 times 3. Okay, we start in the easy method by multiplying the factor 3 by 7, which is in the ones place. 3 times 7 is 21. Then we multiply the 3 times the 0, which is 0. Then we multiply the 3 times the 9, which is really 900. 3 times 9 is 27, plus 2 zeros behind it, 2,700. I add those together, and I get a grand total of 2,721. In the traditional algorithm, I start the same way. 3 times 7 is 21. The 2 is going to go up. Oh, that doesn't even look like 2. Plus 2. Let's try that again. Plus 2. And the 1 goes down. So 3 times 7 is 21. Then I multiply the 3 times the 0, which is 0. 0 plus 2 is 2. 3 times 9 is 27. So I write my 27 here. 1, 2, 3, comma me, and I'm done. Notice that I got the same final product, but it did take me less room. It's like a shortcut. In this video lesson, you have learned how to use the traditional multiplication algorithm when multiplying a 3-digit number by a 1-digit number.